Welcome students, I am Tanmay and welcome you all in the channel Chemistry and History of Molecules. So today we are going to learn about a very important topic for Furan synthesis, that is Feist-Benary method. So previously I have made a video for the preparation of Furan using Paal-Knorr's method. I suggest you please go through that video first, after that you come here, it's a continuation. Secondly, this reaction is difficult, I accept. It is difficult to understand and I think many students have problem understanding this video. So since the topic is difficult, I will try my best such that you can understand. And for you, I want to say something. First of all, read the whole video. Don't skip. Second, try to understand from the first time. If you can't, read the video again. And after that, if you still can't understand, please write me in the comment box. I'll try to explain the things more details. So this is the thing, and I will first start with retrosynthesis. Why? Because if you understand the retrosynthesis properly, if you forget the method also, you can design. So that is the reason. So I suggest you please learn retrosynthesis because it is very important, and secondly it will improve your knowledge. So let's start. So first, if you look at Furan, Furan looks like it's this molecule. So we can consider the backbone in this way. Don't consider it's a tetrahydrofuran. I'm not saying about that. Don't go that. So this is the backbone. So let's consider it in this way. So previously we have done Paal-Knorr's method. How we have achieved Paal-Knorr's, how we have disconnected this molecule in this way. Means the corresponding okay, if we do exactly same. So means this is a carbonyl, 1,4-dicarbonyl compound. Okay, and medium is acidic. But here we will explain, we will do this Feist-Benary method, medium is alkaline. Okay, so means how we approach, first we will discuss about the basic concept retrosynthetic analysis, then mechanism, then intermediate which supports the mechanism, and this is, you can see it's a difference. Fine. So in this method, this is the Paal-Knorr. So how Feist-Benary? So let's consider in this way. This we will now disconnect this way. Okay, so this way to prepare phenol. How? So we can think that let's draw with respect to the carbon based backbone. It will be easy. This. So how? Sorry. This is oxygen, this is carbon, and this is carbon, plus this is carbon, this is carbon. Okay. So this is the thing. Now two ways this could be done. Means now these are the fragments of our target. Now we have to design reactivity pattern, means nucleophile electrophile in that way. How? So one chance, one strategy is that this is delta minus, and always keep it in mind, oxygen should always be minus, it can never be plus. Okay, means positive state, because there is one exceptional example, that is OF2 or O2F2. These two is the exception, but in reality, in this case oxygen is delta plus, but other case oxygen is always delta minus because of its exceptionally high electronegativity. So wherever we design, this is delta minus fixed. So if it is delta minus fixed, then this carbon is delta plus fixed. Now where is our change? These two carbon will change the polarity. So if it is delta minus, for hypothetical thing, this is delta minus, this is delta plus 1, and another is, this is the retrosynthetic strategy. This is delta plus and plus, this is delta minus, this is delta minus. So two ways the synthesis could be designed. Okay. Now these are the strategies. Now we have to come with the real synthons. What are the real synthons? For example, if you see this, the real corresponding real synthon for this, let me clean it. Means real synthons, what do I mean? We thought the polarity of carbon will be like that. I agree. But how to get or which molecule will provide such type of reactivity? That is the real synthon thing. So we can think that this could be active methylene compound. How? CH2 C double bond. You can say that, sir, instead of CH2 you can also take simple carbonyl compound, because we know that alpha to a carbonyl is also negative. I agree, but you have to generate a carbonyl. So active methylene generates carbonyl easily because the corresponding negative charge is in delocalization with 2 carbonyl, more stable. pK is lower, around 9 to 10. So that is the advantage why we choose active methylene. Fine. This, how will you get? Plus means we can consider this is a carbon. Plus, along with that, see 1-2 relation. So this is a carbon, but when we say alpha to alpha carbonyl, then it's a negative. That thing could be changed by providing a halo. You know alpha-halocarbonyl compound, I have discussed about the halogenation of ketone or carbonyl under acidic condition result in monohalo. So this is the strategy to obtain this. And this is a dicarbonyl compound. I'll in future in a dedicated video I'll discuss how to prepare this 1,3-dicarbonyl compounds. Fine. This is one. Second strategy. This is plus, this is minus. So we can think this plus means carbonyl, and how to get O minus? Alpha hydroxycarbonyl, because oxygen will always be minus, can't be plus. This is plus. Now right now oxygen, this is minus. So here also, just I forgot to mention, this was minus, this, and this oxygen is this. Similarly, this is plus, this carbon is also plus, because of the chlorine. Because of the chlorine, if this chlorine absent, then this is definitely delta minus. Okay, this is the normal reactivity and normal polarity. There are some exceptions or inversion polarity or Umpulam observed, but those are exceptions. Right now we'll focus on the normal. This is easier. Fine. Now how this could be obtained? Minus plus. Okay. One is simple carbonyl thing, or you can say dicarbonyl compound. This. So if we focus on this center, this is delta plus, this is delta minus, plus minus. This relation, fine. Another could be in situ generation, like diacetylene dicarboxylate. I will come later. OET, or I will come this thing later. It doesn't matches regular basis. I'll explain. So we have learned the disconnection approach, and what is the real counterpart molecule. Means first we will focus on this methodology. Means what we will do, we will take active methylene compound and we will take alpha halocarbonyl to perform the reaction under alkaline condition. Okay. So let's see the exact reactions. Okay. So now you can see this. So what is the reaction? As I told, this polarity means oxygen delta minus, carbon delta plus. This oxygen is delta minus 1, 3. This carbon is delta plus. Fine. This is carbon is delta plus. Here carbon is delta plus. This part, and carbon is delta minus. Sorry. I guess I made mistake. Okay, I made mistake. This should be actually the second one, delta plus. Fine. So now focus on this delta plus. So this is delta plus and this is also delta plus because of the C. Fine. Now in presence of dilute alkali or tertiary amine base, what the message this reaction want to provide us? The message is that tertiary amine base or dilute alkali can only abstract the proton from here, because there are other side reactions possible. For example, if it is an alpha halocarbonyl, You may think that base can undergo substitution reaction first. Second, it can undergo aldol condensation with some other substituent at this place. So lots of possibility are there. But if you use dilute alkali or tertiary amine base, which are also weaker base, so those reaction will not happen. What reaction will happen? This proton will be abstracted to prepare OET. This is C minus, CH minus, this. So, and this part, this molecule is resonance stabilized. Resonance stabilized by what? Because the conjugation of these two. I am not going to explain resonance part. Fine. So this is resonance stabilized. Just accept. Resonance stabilized. Fine. Now, see, this is a nucleophile. So, expected that which center it will attack. It will attack this. This is also electrophilic center. This. Now, there is a question that if you see the attack part. Okay, I believe I should say show one canonical form. This will be easier. So this is CO OET double bond CH O minus. This means this charge can come here and it can open this way. Why I am showing this? See, the nucleophilic center could be this or could be this. Okay? No. There is a wrong thing. This should be minus because this is plus. I have made mistake. This should be minus, and not only this, this should be minus. Fine. Fine. Now you can see there are two type of nucleophilic center. Two type of nucleophilic center means one is carbon based nucleophilic center, this, and another is oxygen based nucleophilic center. So which will attack? Question, always we have seen in case of active methylene that this carbon center attacks. Okay? In case of aldol condensation we have seen one exception you have observed, that is when you have an enolate which is in resonance with its this is enolate. If you react with trimethyl silyl chloride, then we have ended up with a protected enolate. This is only one exceptional case. Other than everywhere, not oxygen, carbon act as a nucleophile. Okay? So this is the exception. Please don't be confused with that. So what we learned from this, that carbon center will act as a nucleophile and attack. So this part is fixed, that it will attack, not this. Fine. Now question, where it will attack? Here or here? Actually attacks the carbonyl carbon. Okay. So because this is the fact, I am giving my explanation to explain the fact. And this thing will be cleared when some intermediate will be isolated. Okay. Fine. This, because there is a pi bond lowering energy, so easily it can break. So it will attack here and it will open. So ultimately what is the product? So COOET this side, this is the carbonyl, this, and this is attached to O minus, it opened, this is one CH Cl, this one. Okay, fine. Now you can see this is medium is alkaline, so what is expected? That it will abstract proton, because previously see base abstracted one proton from here and that proton could be shifted to this. Understood? This part. Now question, what will be the next? See, still this there is one another hydrogen. This is also active methylene group. So under this alkaline condition, or you can say this is alkoxide what was generated, can abstract this proton because alkoxides are stronger base and this is strong acid. So they will react, so these will be abstracted. Actually this is the mechanism we are discussing. So base will abstract this proton. Fine. So carbon ion generated. CO2ET I suggest you also write with me. It will be a practice for you and this will help you in the exam hall. So don't waste your time by only watching. Just watch along with write. This is the best. So carbon ion is at this center. Fine. This carbon ion has a resonance stabilization like other 1,3 dicarbonyl compound. How? Means it will come here and it will open. So this is CO2 ET. This, now there will be a double bond. This, so this is the OH, this is CH, this, and this is Cl. Fine. Now you can see this is O minus, carbon ion generated. So what it will do? It will instantly attack here this. You may think that sir, chlorine same side. So in order to avoid confusion, let's write it here. Chlorine is this side. So it will attack and this bond will go. Why it will? Because intramolecular reaction. 2 points. One is intramolecular reaction, which is always favored over intermolecular, and second, 5-member ring. 5-member ring formation. Why it is important? Because we know that 5-member ring formation is both conformation, proper conformation orientation is achieved in case of 5-member ring formation. That's why this will happen very easily. Fine. So what is the product here? This will result CO2ET, C carbon O, having this something substitution. This is the OH. This is this. Okay. So there are one hydrogen and this. So this part we have achieved. Let's clean this. Now what is the next stage? Actually 5-member ring is formed. Now question, what it will do? See, this we have obtained. Now you can see, in order to have furan, we need to eliminate this water. Okay, medium is alkaline, so this, it will come, it will go. Is it visible? Okay. This, so what is the product? This. One substitution here, one is here, one is CO2ET, and one is another substitution which I forgot to mention here. So this. Now our target furan we have achieved. Okay, so this is our target product. Now question, why this reaction, this step happen? Not only this, you can explain another way that it can push, it can pull, and it can leave, may resulting into, that's also a logical explanation. This oxygen is having a plus charge, this, here is one bond, there is CO2ET, this, and there is hydrogen. Now next stage, this hydrogen will be abstracted to this, because right now it is activated. So both mechanisms are possible. Now question, why this step happened? What is the driving force for this elimination of water? That is very important topic, aromatization, because the product furan is aromatic. So in this way, first strategy of Feist-Benary method, this to prepare furan. Now question, as I told, what type of intermediate is, how to prove that this is happening in this way? This is the intermediate. Just forget all the arrows, or let me clean it for your better understanding. So this intermediate is isolated. I'll give you the example that which exactly such type of intermediate isolated supports this. So learn again what's happening. First of all, we have taken this disconnection approach because 1 minus plus C. Always remember, I made mistake, don't do that. that opposite opposite charge should react each other. Means this is negative positive, negative positive. So negative positive, negative negative, positive positive. So this first react in presence of base, weak base, then nucleophilic attack, and these you can consider as aldol type reaction. Aldol reaction. That type. Aldol type reaction. Then preparation of beta hydroxy carbonyl derivative. See, this is carbon, this is alpha, this is beta. So instantly you could have been said that, sir, this is beta hydroxy carbonyl, aldol condensation. So instantly it should have been tautomerized. I agree, it can tautomerize, but before that, what is the most important thing? That is a carbonyl formation. So this is the thing, in this way base catalyzed condensation happen. So that condensation have a conjugation. Now question, instead of double bond formation, why this step is easier? Because intramolecular reaction is faster over intermolecular. That is the reason, that's why this step happens in this way and ultimately result in this intermediate, and which undergo furan preparation because of aromatization. Okay, so this is, so let me give you a real example in this context. Okay, so you can see that this is the real reaction. Okay, this should be hydrogen. So this is the real reaction where this intermediate is isolable. Okay, so this is the real proof that such intermediate could be isolated, and this indicates that reaction, this carbon ion in presence of base, actually I should write base, in presence of base, here the generated carbon ion attacks at this carbon, not the other one. Why? Let's think about the other one, if it is. So what was the product expected? CH, this attached to Cl, so carbonyl group should be here. Okay, carbonyl group is expected to be here. Then what we have obtained, they react and ultimately produce, like in Paal-Knorr's method. So no hydroxyls present would be detected here. Okay, but here this is isolable, so indicates that reaction happens in this pathway, not this pathway. Okay, okay. Now let's go to the second part, and that is the another discussion approach. Okay, let's continue the discussion. Now as you can see, the discussion approach which is changed means the second method, second strategy. This is minus, this is plus, this is minus. So it means this is an oxygen anion, and this is carbon ion. If it is carbon ion, so first of all you have to generate carbon ion. So this in presence of base, what it will do? It will result in this CH minus CO2 ET double bond. This similar way they will react. How? This carbon ion will attack here and open up. So what it will result? So this is OH. This is OH, this CO2 ET. The role of this CO2 ET just only one thing, increase the acidity of protons such that reaction became easier. So CO2 ET fine. This is O, this fine. So this is the method, this. Now as you can see, like previous time, this is also possible, it can undergo, means I'll give you details. Don't jump too much step, it will not be healthy for you. So this is OH. So base means should not do the resonance. This is base. What it will abstract this proton? So minus here, this, and CO2 ET. Fine. Now the base, so it is true that in previous case what it has done a resonance, means it can come, it opened, and after that there was a chlorine. That's why this oxygen attacked, because chlorine was a good leaving group, but see, hydroxyl is not a good leaving group. So what is the alternate option for this anion? Alternate option is here, this, because it is an aldol, elimination of beta hydroxy carbonyl. So what it will do? It will eliminate. This is OH, this is double bond, this is CO2 ET, and this is the carbons. This is the carbonyl group. Now in medium there is base. So what base can do? Base can abstract this proton to generate the O minus. This double bond CO2 ET, carbon this. Now this is, see, intramolecular reaction, 5-member ring. This is the oxygen ion, this is the carbon center. Nucleophilic electrolysis will attack, it will open up. So what it will result? It will result in this to form this oxygen double bond, this OH. Fine. This CO2 ET. Actually, this is also that beta-ketocarbonyl type. I am not saying exact type. How? See, this oxygen can push here, it can come here, it can leave. So what is the product? 5-member ring. I was always draw the ring as it is. Then double bond here, oxygen plus. Second, sorry. I made mistake. Not oxygen. There is one proton here. It's a vinylogous type. So oxygen will be there as it is. Base will abstract this proton. It will come here in this way. So one bond here, one bond here. What are left? So this is one substitution. This is CO2 ET. I guess there is one mistake. This carbon valency 1, 2, 3, 4, 5. It should not be. Where there is same problem, there is same problem, there is same problem, there is same problem. Here is. So this. So in this way, the Furan derivative will be prepared. So this is the first method. Means, what is that thing that here the polarity of the reagent exactly matches as we have written. But the second example is little interesting. Why it is interesting? Because see, in case of acetylene dicarboxylate, the polarity is not matching exactly. And that is the interesting part. You should learn that always we cannot take a particular polarity reagent at the beginning. But one thing may happen that during the reaction or during the process of reaction, some intermediate will be generated which can fulfill the criteria of this reagent. And this is exactly happening in the case of this acetylene dicarboxylate reagent. How? See. Carboxyl group withdrawing. So this is delta plus expected. Similarly, this is delta plus. Alpha hydroxycarbonyl is fine. What we have shown that this is influence of base delta minus. This is delta plus. So this part is fine. But this part is not. See, there is one delta minus. So where this criteria is fulfilled? Apparently it looks like that this is not fulfilled, but actually it is fulfilled. So this part, keep it in mind. Question. So what happens if you do the reaction? So let me draw the date again. This is OET, this is OET. So this part is fixed. Now question is another one. Okay, so let's look at this. So in presence of base, what is expected? In presence of base, that is in presence of base like K2CO3, potassium, weak base. So what it will generate only alkoxide. So double bond O, PH, O minus, fine. And see, this is a ester, but you can consider it a vinylogous ester. Generally, vinylogous ester means this thing is called vinylogous ester. Okay. But here triple bond can also show the similar property. That's why we will consider these also as a vinylogous ester. Fine. So what is expected that these O minus will attack at this carbon. It will come here. It will open. So what is the product? It will result PH double bond O double O minus. Actually, it is attacked. So this with C double bond C double bond C O minus and OET. Okay, and here CO2 Et. Now look at properly. Now the interesting thing appears. What is the thing? Generally we have seen in case of ester attack, some group leaves, but here there will be no leaving. So it will push, it will not leave because it's not tetrahedral intermediate. It will open up this. So, but see, this is not in conjugation because this pi bond and this pi bond is perpendicular plane, allene type system. Okay. So this is the pH, double bond O, oxygen pH. This double bond here CO2 Et. There is carbon having minus. This is C double bond O OET. See, now a carbanion is generated as an intermediate. Previously, just look at this carbon. This was also delta plus always. But right now this carbon becomes delta minus, and that is the advantage. That's why I'm telling that during the course of reaction, it changes its polarity because of specific design. Okay. So what happens? Now this attacks, and it opens up this. So what is the product? pH, oxygen O minus, this is the pH O. Now see, check the number 1, 2, 3, 4, 5. So 5 member ring form. Just form the 5 member ring. Now there was a double bond previously, and with oxygen there was a CO2 Et, and now this carbon also is attached to CO2 Et. This. See, it will abstract a proton from the reaction medium to prepare this beta hydroxycarbonyl type derivative. Fine. This is a concentration aldol type attack. So consequently, next step what will happen? There is another hydrogen here. So in presence of base, so base like K2CO3 means actually sorry, I made mistake. So this step it will end up at this stage. Reaction will end up at this stage in this case. Next is acid catalyzed. Next is acid means HCl in methanol. So what it will do? This H plus will be attached here having a plus charge. This is the reason. So actually this reaction don't end up directly there. We need to put some acid in order to control, because we know that water OH is not a good leaving group in alkaline medium. But if you put acid, it becomes a good leaving group because of OH to plus formation. So it will leave. So what it will result? This CO2 Et, pH having a plus charge here with pH and H. Now see, this plus charge is resonance stabilized by this double bond. Let me draw it. Let me draw at least one. It will be easier for you. So CO2 Et, this is the pH, this is the pH H. So first of all, this is benzylic, no problem. Second of all, this double bond can coordinate and stabilize the positive charge, means here, this. And now this oxygen can stabilize this. So ultimately, this is the second and this is the third canonical form, this having a plus charge. So every atom is now octet filled, so it will undergo this process. Fine. So next, this proton will be abstracted. So ultimate product is, means by water molecule, or we actually not should, I should say water, actually I should say methanol, because methanol is given. So methanol molecule is expected to abstract this proton, this CO2 Et, this is CO2 Et. Fine, this is. So this is the target fuel. So this is the overall discussion, and this is the end of this discussion. I'm sorry, I know this is a big exhaustive lecture. So thank you everyone for listening. What we have covered today? We have covered today the synthesis of furan using Feist-Benary synthesis. And the main difference of this Feist-Benary with Paal-Knorr is acid mediated, one for dicarbonyl compound mediated, but this is alkaline. All over the process is alkaline. Yes, some exception I have HCl, but main ring formation is happened using alkaline medium. Fine. Second, we have discussed on retrosynthetic strategy, that polarity of this group, how this polarity, and with respect to the retrosynthetic polarity, what is the real counterpart of that retrosynthetic fragment. Okay, so this we have learned with mechanism. So thank you everyone for listening. So this is the end of this discussion. So if you like my teaching, I repeat, if you like my teaching, please help me to grow my channel. First of all, please subscribe my channel and please press the bell icon to get the notification of every single video I upload. Second, share this video as much as possible, and I'll be very happy because many people are getting benefited from my effort. Thirdly, please like this video and make some good comments. It's a very good achievement and satisfaction as well as inspiration for me to make some new video for you in future. So thank you again. See you in my next video. Till now, God bless you.